Miss Hollingsworth. I got your question, but you're having problems with either finding GCF or LCM, least common multiple, or greatest common factor. Wasn't quite sure which one was giving you problems, but by your message, I guess you're having problems with one of the two. So I thought I just made up this example to go through, and if you need more examples, just email me a problem and I can create additional examples. First thing, if you want to find either GCF or LCM for 9 and 12, I mean, there's different ways you can do this, but you mentioned particularly in your question about using prime factorization, and so 9. First thing you want to do is break them into their primes. I picked relatively small numbers. I mean, 9 is 3 times 3, or 3 squared. And then the other one is 12, which is 4 times 3, and then we can break 4 down into 2 times 2 times 3, or 2 squared times 3. And so the prime factorization of 9 is, we break it into 3 squared, and 12 is 2 squared times 3. Now, if you want to find the GCF for these two numbers, what you want to do is see, what factors do they have in common. Here you have a 3 that's repeated. Here you have a 2 that's repeated, 2 squared, and we have a 3. If you want the GCF, greatest common factor, what factor do they both have in common? Well, they both have, this one has 1 3, this one has 2 3s. So they both have 1 3 in common. And so the GCF is just that 1 3 they have in common. Now, the least common multiple, you got to think about the opposite of that. For the least common multiple, you want every factor here in the least common multiple. What factors do we have here? We have a 3, we have a 2, and a 3. So every factor will be in the LCM. So we'll have 2 and 3 in the LCM. The question is, how many of each? Well, if you look up here, if we look at 2 first of all, we have 2 2's here, we have no 2's here. And so you always want to pick out the bigger number of 2's in either location. We have 0 2's here, we have 2 here. Well, that means we want 2 2's in the final answer. If we look at the 3's, we have 1 3 here and 2 3's here. Well, which one's the bigger number? With the 2 3's. And so we want 2 3's in our LCM. And so then you just multiply here. 2 squared is 4, 3 squared is 9, 4 times 9 is 36. This is one way to work it with prime factorization. So, if you have 9 and 12, the smallest number divided into both of them with a remainder of 0 is 3. And the opposite of that, least common multiple, what's the smallest multiple that both these numbers go into? Well, 36. Hope this helps.